Chapter 10, Section 2, Arcs. We're going to spend 2 days on Chapter 10, Section 2. Today we're going to talk about arcs, and then tomorrow we're going to talk about something else. Arcs of circles. An angle whose vertex is the center of a circle is going to be called a central angle. We need to go over a couple of vocabulary words before we get into the arcs part. So if an angle's vertex is the center of a circle, it's going to be called a central angle. If the measure of a central angle is less than 180 degrees, the points on the circle in the interior of the angle are going to form a minor arc. If the measure of a central angle is greater than 180 degrees, the points on the circle in the interior of that angle are going to form a major arc. If the endpoint of the arc are the endpoints of the diameter, then the arc would be considered a semicircle. If you notice, I have circle P, and then I have a couple of points on the circle A, B, and C. Notice I have the angle APB. Angle APB would be considered a central angle because point P is the center of that circle. Inside of my central angle, APB, I would have this arc, which would be all the points on the circle between point A and point B on the interior of angle P. This would be considered a minor arc because angle APB is less than 180 degrees. The rest of the circle, from points A to B going in the opposite direction, including point C, would be considered a major arc because notice when I'm talking about that arc, the angle APB, but going the opposite way would be way more than 180 degrees. Notice, for notation, a minor arc is going to just be named by their endpoints. So the endpoints of this arc are AB, so we would name it arc AB. Notice the notation now, it's kind of similar to a segment or a line, but now because it's an arc, it's going to be a curved line over the 2 points. A major arc is going to be named based by their endpoints and by another point on the arc. So when I'm trying to name the major arc, or the blue arc in this circle, I need to use the endpoints A and B, but I also need to use another point that's on that arc, which would be C in this case. So this arc is going to be named arc ACB. Again, I have my arc notation, and this time, notice that I have 3 points. C is going to be in the middle because A and B are the endpoints, so they need to be first and last. Measuring arcs. A complete circle measures 360 degrees. The measure of a minor arc is the same as the measure of its central angle. The measure of a major arc is going to be the difference between 360 degrees and the measure of its associated minor arc. The arc addition postulate is very similar to the segment addition postulate, and it says the measure of an arc formed by 2 or more adjacent arcs is going to be the sum of the measure of the arcs. This first example asks us to find the measure of each arc. We can tell whether they're talking about a major or a minor arc based on the notation. We know A, when they're asking for the measure of arc CD, it's going to be a minor arc, or less than 180 degrees. But we know in question B and C, they're looking for the measure of the major arc because it's notated with 3 points. Notice in this diagram, they've given us that angle CAD is 148 degrees. Well, arc CD would be all of the interior points of the angle CAB. So because angle CAB is 148 degrees, arc CD, the minor arc CD, would be 148 degrees. Now they want us to find arc CDB. When you're looking for arc CDB, notice I'm going to have to, it's going to be this whole circle except for the little sliver right between B and C. So what I need to do here is I need to take the 148 and I need to add the measure of the circle from D to B, which would be 180 degrees because that segment DB would be the diameter. So I'm going to add 148 plus the 180, and arc CDB would be 328 degrees. And then when they ask for the measure of arc BCD, that would be the diameter. BD would be the central angle, which means it would have an angle measure of 180 degrees, so the arc measure would be 180 degrees. This next example asks us to find the measure of each arc. The first one that they ask us for is arc BD. We know they're talking about the minor arc because of the notation. If they were asking for a major arc, then they would include another point that would be on the included between the two endpoints. Because arc BD is created by two central angles, BAC and CAD, we can add those angle measures and it will give us 142 degrees. Then they want us to find the measure of arc BED. We know they're talking about a major arc here because it's notated with 3 points. It's created by central angles BAE and EAD. Notice we do not know the angle measure for BAE right now because it's not given to us. However, I can find it by adding the angle measures that are given to us and subtracting those from 360. So I would need to add 100 plus 82 plus 60 and subtract that from 360, and you get 118 degrees for angle BAE. So to find the major arc BED, I would need to add 118 plus 100, which would give me 218 degrees. And then for the minor arc BE, it would also be 118 degrees, like we just found. Congruent arcs. Two arcs of the same circle or congruent circles are congruent if they have the same measure. This next example asks us to find the measures of arc AB and arc CD, and it also asks us, are the arcs congruent? So if you look at example A, we have the same circle. Remember, the radius of a circle is always going to be the same all the way around it. So the measure of arc AB would be 60, and the measure of arc CD is also 60 degrees. Because these are two arcs from the same circle with the same measure, we can say the arcs are congruent because they are on the same circle and have the same measure. In example B, to find arc AB, it would be the minor arc, remember, because it's only notated with the two endpoints. Arc AB would measure 135 degrees. Arc CD would also measure 135 degrees. In this case, again, my arcs are going to be congruent, but this time they're congruent because they are on congruent circles and they have the same measure. How we know that they're on congruent circles is that they tell us with the tick marks that the radii are going to be the same for the two circles that they've given us. For example C, they want us to find the measure of the minor arc again, remember. They tell us the major arc here would be 210 degrees. So we would take 360 minus 210, and it would tell us that the minor arc would be 150 degrees, and that's going to be true for arc AB and for arc CD. So these two have the same measure, but are they congruent? They both have a measure of 150 degrees. However, these two arcs are not congruent because they are not on congruent circles. Circle CD and circle AB, the circle with AB, do not have the same radius. Today's assignment is on page 607. It's numbers 2 through 38 even.